Yeah, hello student, this is the third part of permutations and combinations. We can call it as P and C, permutations and combinations. Permutation means arrangement of things or objects. Combination means selection of things or objects. So first of all, we need to complete the concept of permutations. Permutations. The meaning of permutations is arrangement of things. So arrangements are two types. One is linear arrangement, another is circular arrangement. Okay, I will explain one by one, students. Okay, students. Permutations are two types: linear permutations, circular permutations. So what is the linear permutation? Arrangement of objects or things in a row. Arrangement of objects or things in a row is known as linear permutations. Arrangement of objects or things around the circle, such arrangement is known as circular permutation. So here clearly given, listen students, each of different arrangements which can be made after selecting some or all finite set of objects is called permutation. If the objects are arranged along a row, then that arrangement is called linear permutations. So what is given here, Nana? Definition of permutation is given and definition of linear permutation is given. Once again listen, each of the different arrangements can be made after selecting some or all of the set of objects is called permutation. If the objects are arranged along a row in bracket line, then the arrangement is called linear permutation. So what is happening here? For example, students listen, A, B, C, D, E are here 5 different objects. From different objects you want to choose some or all. So in permutation two things are involving, no? Combinations and permutation both are involving. First thing is you need to select some things. You need to select some or all. You can select 1 or you can select 2 or you can select 3 or you can select 4 or you can select 5. So for example, I want to select 2. So after selecting those 2, you want to arrange those 2 in a row. That is called permutation. Okay. From this 5, selecting 2, symbolically written as 5p2. What is the value of 5p2? We will discuss later. So from these 5, selecting 2, after arrange them, those 2 in a row is denoted by 5p2. None. Okay, clearly given now. Here clearly given. So each of different arrangements can be made after selecting some or all. From 5 you can select 1, you can arrange that one. From this 5 you can select 2 and you can arrange them. From this 5 you can select 3, after that you can arrange them. From this 5 you can select 4, you can arrange them like that. Okay, you can select all and you can arrange all. Okay, yeah, that is called permutation. If the objects are arranged along a row, okay, then such arrangement is called linear permutations. So if the objects are arranged around a circle, such permutations are called circular permutation. Nana, we will discuss circular permutations later. Okay, just we need to complete linear permutation, arrangement of things along a straight line. So here also listen all of you, A, B, C, D, E, F, some 6 different objects are there. That is case 1. Case 2, A, B, C, D, E, F. This is case 2. So in what I am trying to explain, in case 1 all objects are different. In case 2 some things will alike, means some objects are alike. Okay. So what happened in first case? From these 6 elements, choosing 3, selecting 3 and arranging 3, symbolically known as 6p3. Okay. So how can you get what? How many ways you can select? How many ways you can arrange? That is different task. So this is another type of situation. Anna. So what happened? All are not different objects. Some are alike. From this element, we want choose 3 and we want arrange in a row. How many different we can arrange? That is different task. So here two types of situation. Situation 1, all given objects are different. In situation 2, in given objects some are alike. So this also we will discuss it later. So one by one. Actual chapter is permutations and combinations. First of all, you have to complete permutation. Again, permutations we have two types: linear permutation, circular permutations. Now, in linear permutation, several situations given all objects are different, situation to some objects are alike, like that. Okay, then in this way you can complete the topic. So first of all, what happened in this part? All objects are different. All objects are different. From these all objects, I want to choose some or all. After selecting, I want arrange in a row. How many ways you can arrange? How many ways you can arrange? You can, that says linear permutations. Okay, listen students. N different objects are there with us. N different objects are there. From n different objects, I want choose R objects, and these R objects I want arrange in a row, that is symbolically written as NPR. So what is the value of NPR? We will discuss now. Okay students? Yeah, listen. 1, 2, 7, 3. There are 4 different numbers, single digit numbers. Using these 4 single digit numbers, I want to create 2 digit numbers. How many 2 digit numbers you can create? So 1 2, 1 7, 1 3, 2 7, 2 3, 7 3, 2 1, 2 means 21, 71, 31, 72, 32, 37. What happened on here? 1, 2, 3, 4, 5, 6 plus 6, totally 12. That is mathematically written as 4p2 equal to 12 mathematically. How you got this value? Just I wrote all possible 2 digit numbers, I counted. So this is possible only when the given numbers are less. If 1 2 7 3 9 8 4 like that 6 given, you want to make 3 digit numbers, I can't write all 3 digit numbers, I can't count. I can, but it will take time. So by using permutations tool, I can say the answer. Means how many ways I can select 3 from these numbers. After selecting this, how many ways I can arrange in a row. Okay, this is concept of permutations. Okay, now listen students. So what I did first of all, by using these 4 single digit numbers, single digits, from those 4 I choose 2 and arrange it in a row. So how many arrangements I got means I can say 12. So this and this actually mathematically you can write 4p2. So this is same as filling these 4 elements into 2 blanks. Both are same. Constructing 2 digit numbers from 1, 2, 7, 3 same as filling these 4 digits into 2 blanks. How many ways you can fill? By using fundamental principle of counting, that is product rule, you can say the answer. So I can fill this blank in 4 ways. I can use either 1 or 2 or 7 or 3 to fill this blank. After filling this blank, I can fill this blank. Important thing is repetition won't allow in the first case. Repetition won't allow means, for example, this box is filled with 2, again you can't use same 2 to fill this first box. That is the meaning of repetition won't allow. See here, no digit is repeated. No, here 22 not there, 77 not there, 33 not there, no digit is repeated. That's why after filling the first blank in 4 ways, second blank, to fill second blank, I will have only 3 possible numbers. So second blank I can fill into 3 ways. First operation 4 ways. Second, after completion of this only I can start second operation. No, what is the meaning of that? One operation is depend upon another operation. What is the meaning of that? We need to use product rule, not some rule. So first blank I can fill in 4 ways, second blank I can fill 3 ways. These 2 successively I can perform into 4 into 3 ways, that is 12 ways means I can say that there exist 12 2-digit numbers. Practically also we got 12. What I am trying to explain, that is important thing students, listen. What I am trying to explain you that n different objects are given, n different objects are given here. N different objects are given. Okay, using these n different objects, selecting some or all. After selecting them, I want to arrange in a row. How many ways you can arrange? That should find. Yeah, what I am assuming, these all are n different things. From these n different things, I want choose R first. Choose R. Actually mathematically that is written as NCR, selection. So we'll discuss later. That is a big problem. So n objects are given. I want choose R from this. R or all I can say. R may be n also. Okay. So what is the actual R? R is lesser than or equal to n here. You can choose 1 or 2 or so on. So what is the value of possible R? N may be R may be 1, 2 up to n I can take. That is the meaning. From these n elements I can choose some or all. So I am assuming that I want choose R elements, and I want arrange those R elements in a row. How many different arrangements you will get? That should find. That is symbolic as NPR. That is symbolic as NPR. NPR equal to what? That should find. What I am saying, from these n different elements, you want choose R elements. After choosing R elements, you want arrange in a row. That is same as filling these n different elements into R blanks. The blanks are arranged in a row. That is important thing. Okay. So how many different arrangements you can made? That is same as filling these n elements into R blanks which are arranged in a row. The blanks are arranged in a row. Okay. So this is first blank, second blank, third blank, R minus 1th blank, rth blank. Okay, students. So how many ways I can fill first blank? N different things are there here. Using any one of them I can fill. First blank I can fill in n ways. I will write once again. Actually I explained this concept again. I want to explain because very important thing. First blank 1b I will write can be filled in n ways. Student, I hope you people understood. Now coming to second blank or second box. Already n distinct objects are there. One is already used up here. So it has n minus 1 different things. By using n minus 1 different things, I want to fill second blank. I can use any one of the thing from n minus 1. That's why I can fill the second blanks in n minus 1 ways. Students, observe. For example, we have 4 nana. I can use any one of them now here. Totally 4. For example, here 1 is used up, means remaining 3 only. No? Say A, B, C 3 means I can use A, or I can use B, or I can use C to fill this blank. What is the meaning of that? How many ways I can fill second blank? 3 ways. Similarly, here n things are there. From n already one thing is already filled. Here the remaining things n minus 1. I want to fill the second blank by using n minus 1. How many ways I can fill means? Simply I can say n minus 1 ways. That's why second blank I can fill in n minus 1 ways. Student, second blank. Now I want to fill third blank. I want to fill this blank. Actual total n, two objects are gone. So remaining things are n minus 2. Remaining objects are n minus 2. From n minus 2, any one of them I can choose and I can fill into the blank number 3. So how many ways I can fill means n minus 2 ways I can fill. Third blank can filled in n minus 3 ways. Okay, students, listen. First blank n ways. Second blank n minus of 2 minus 1 ways. I want 2 here. Second blank, no, that one. Third blank n minus of 3 minus 1. Fourth blank n minus of 4 minus 1. So on. Rth blank n minus of r minus 1 ways you can fill. But I want to fill all, no. All the elements I want to fill into r blanks. So by using product rule, all these operations can be performed in n into this into n minus 1 into n minus 2 into so on. What is this, Nana? N minus r plus 1. Therefore, how many ways we can fill all those n different elements in r blanks which are arranged in a row is nothing but n into n minus 1 into n minus 2 and so on n minus r plus 1 ways. That is symbolic NPR equal to n into n minus 1 into n minus 2 into n minus 3 and so on n minus r plus 1. Student should take care at last. Again I want to write, there is not clear now. I will write down. So what is so on? So on n minus r plus 1 ways. So this is the answer. So I will explain through one example, students. So first of all I want say one thing to you. What is that? Here see notations. The number of permutations of n dissimilar things taken, distinct things or dissimilar things, both are same, taken r at a time is denoted by NPR. P R. Some books they are giving justly P n comma R, P n comma R, C n comma R, like that. Combinations, permutations, selections, groups, arrangements. Okay. So NPR P of n minus R. But that is one thing. Yeah, what is this? Later I will discuss what is that. Later I will explain you. Okay. Yeah, NPR means what? Here clearly given NPR. NPR means n into n minus 1 into n minus 1 n minus r plus 1. Now I want to prove this NPR value. What is n? What is r? Everything is here mentioned. The number of permutations of n dissimilar things taken r at a time is equal to the number of ways of filling r blank places arranged in a row by n dissimilar things. Okay. You want to write notes? You can write in this way. So this is theorem. This is the theorem actually. So NPR equal to this. How to prove NPR equal to this? Just I prove, no. So you want to write notes in this way, you can write the number of permutations of n dissimilar things taken r at a time is equal to the number of ways of filling r blank places arranged in a row by n dissimilar things. Okay. So what happened here, Nana? First blank place can be filled with any one of n things in n ways. Since repetition not allowed, this is important, repetition not allowed. Okay. Second blank place can be filled in n minus 1 ways, by fundamental principle of counting. And actually from fundamental principle, that is product rule. First two blanks can be filled together in n into n minus 1 ways. Similarly, first three blanks can be filled in n into n minus 1 to n minus 2 ways. So on. So first r blanks places can filled into n into n minus 1 into n minus so on n minus r plus 1 ways. That I wrote here now. Therefore, the number of permutations of n things taken r at a time. NPR means that one, number of permutations of n things taken r at a time is equal to NPR, that is equal n into n minus 1 into n minus 2 so on n minus r plus 1. Okay. So in this way we need to remember now. Again I want to write here, students, listen, important now, how to remember NPR equal to n into n minus 1 into n minus 2 so on n minus r plus 1. Okay. For example, 5p2 is equal to what? That is interesting. 5p2, n equal to 5 nana here, r equal to what? 2. First of all, try to find, right? First of all, we need to 5 into bracket, so on. How many brackets we will get? This depend upon the value, last bracket. What the last bracket value should find here? What is the last bracket should find? 5 minus r means 2 plus 1. 5 plus 1, 6 minus 2, 4. What the meaning of this? Last bracket is 4. 5 after 4 only directly. N na 5 only. 5 minus 1, 4. So what is the 5 minus 2 won't get here. 5 minus 2 won't get. 3 won't get because last bracket only 4. No. What is the meaning of that? 5p2 means 5 into 4 only. 5p2 means 5 into 4 only. That is 20. The value of 5p2 is 20. I hope you people are following. For example, Nana, see here. Yeah, listen. For example, 10p3 you want. 10p3. First start with 10 into 10 minus 1 into 9 into 8 into what? Up to how many products you want? That is depend upon last bracket. What the last bracket should find here? N means 10 nana, minus 3 plus 1. 10 minus 7 plus 1. What nana? 8. Up to 8 you want, right? Completed. No, you can't write into 7 into 6. Not correct. Completed. 10p3 means 10 into 9 into 8. Okay. One more thing I will explain. Listen, interesting thing. For example, 12p5 you want. 12p5 you want. 12 into 12 minus 1, 11 into 10 into dot. How many terms you will get? How many products you will get? That is interesting. How many is depend upon last one. What is the last one, Anna? N means here 12 minus 5 plus 1. 12 plus 1. 12 minus 5, 7. 7 plus 1, 8. Up to 8 you want, right? 12 after, 11 after, 10 after, 9 after, 8. Now here you need to stop. So that is the value of 10p5. In this way you can use this formula. What is the meaning of this? There are 12 different objects. From 12 different objects you want to choose 5. After choosing or selecting those 5, you want to arrange in a row. How many different ways you can arrange means I can say 12 into 10, 11 into 10 into 9 into 8. Okay. So important thing is important observation, Anna. Important observation. How you are getting 5p2? 5 into 4. 5 should reduce up to 2 times. 5 into 4. 10p3 means 10 into 9 into like that. 10 should be reduced up to 3 times. 3 times. 10 into 9 into 8 completed. In this way you can remember. In this way you can remember. 12p5. 12p5. 12 into 11 into 12p5. 12 should be reduced 5 times, Nana. 12 into 11 into 10 into 9 into 8. Count 1, 2, 3, 4, 5. Completed. Okay. In this way you can remember. In this way you can remember. Listen, all of you. For example, you want 6c4, you want 6p4, you want. No need to use any formula directly. 6 into 5 into 4 into 3. So 4 times should need to reduce 1, 2, 3, 4 completed. So 6 into 5 into 4 into 3. What you will get? That is the value of 6p4. Okay. So clearly NPR means product of R. Product of 4, 4, 4, 4. Product of R consecutive decreasing digits beginning with n with common difference 1. Understood? NPR means what? Directly. This is just like note. Okay. After proving this thing, how can you remember this result means using this note you can remember. None. How? NPR means product of R consecutive decreasing integers beginning with n with common difference 1. Same, no? With beginning n with common difference 1. So 7p3 means what, Nana? So decreasing product of decreasing consecutive integers beginning with 7 common difference 1 and 3 terms, 7 into 6 into 5. What is the value? That is 7p3. That is one thing. Students, important note. For mathematical convenience, 0 factorial is treated as 1. Okay, now we have, okay, leave it. Now we have the formula for NPR. So what is the extension formula of NPR or another formula there for NPR? I will explain that. What is that? This. Another for NPR. NPR is another way can be remembered as n factorial by n minus r factorial. In previous formula, no factorial, nothing. Just NPR means n should be reduced up to r times the product, continued product only NPR. So here another formula is given. Another way also you need to remember this. NPR means n factorial by n minus r factorial. N factorial by n minus r factorial. How we will get this? I will explain now. This is IMP. But students, rather than this formula, we need to use this. This is easy. Okay, now I will prove that is not big problem for me. NPR n into n minus 1 into dot means n minus r plus 1. That's all. To get the result, what I am doing, I am numerator and denominator of RHS should be divided by n minus r factorial. Into n minus r factorial by n minus r factorial. Even though n equal r also no problem, no? Actually you can't divide with 0, but here I can divide with if n and r both are same, this becomes 0 factorial. But mathematical convenience 0 factorial is treated as 1, no problem. If n is equal r also, the formula is valid. Now observe students how I am expanding that. So denominator is n minus r factorial, don't disturb it. So numerator n into n minus 1 into n minus 2 into n minus r plus 1. After that what do you have? N minus 1 factorial we have. For example, k factorial means how can you write, Nana? K into k minus 1 factorial you can write, no? Derived. So this how can you write? K into k minus 1 into k minus 2 factorial. I will show you. Students listen, Nana. For example, 5 factorial is given, Nana. How can you write? 5 into 4 factorial I can write. or 5 into 4 into 3 factor I can write, 5 into 4 into 3 into 2 factor I can write. So decreasing, at last you need to end with 1 factorial, no, we can't say that minus 0 factorial, minus 1 factorial, minus 2 factorial, not correct, no. So what happened, 5 into 4 into 3 into 2 into 1 factorial, ended, we can't write further, understood? That's why, listen students, 8 factorial is given. How can I write 8 into 7 factorial, or 8 into 7 into 6 factorial, or 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 only, no? At last we need to end 1 only. Okay, so what I am trying to explain you that k factorial is given, Anna. How can you write k factorial? K into k minus 1 factorial, or k into k minus 1 into k minus 2 factorial. What is this? K into k minus 1 into k minus 2, so on, 2 into 1 I can write, what is the problem? At last we need to end with 1 only, no? What is the meaning of that? K factorial means just actually product of first k consecutive natural numbers, 1 into 2 into so on up to k only. You write in reverse, k into k minus 1 into k minus so on up to 3 into 2 into 1 only. Okay, so that one I want to use here. Students listen. Here r minus 1 factorial means what I can write? R minus 1 factorial can be written r minus n minus r into n minus r minus 1 factorial. Okay, so what I can write? N minus r minus 1 factorial. More generally, I want to erase this because space not sufficient for me. Listen students, NPR equal to n into n minus 1 into n minus 2 dot dot n minus r plus 1 decreasing. After this what I got? N minus r we got. After that what you got? N minus r minus 1 you got. What happened? Decrease, n is decreasing, n minus 1, n minus 1, n minus r plus 1. After this 1 decreased this, 1 decreased this, so on, 2 into 1 only, no? By n minus r factorial. Observe students, what is the numerator? N factorial, numerator 1 into 2 into so on into n. What is the continued product of first natural numbers only, no? That's what is the numerator, n factorial. What is the denominator? N minus r factorial. What is this? NPR. So second formula for NPR. The second formula for NPR. NPR equal n factorial by n minus r factorial. Now I want to conclude students. I don't want to waste your time. I want to conclude here. Two things are there for NPR. NPR can be remembered as n into n minus 1 into n minus 2 into so on n minus r plus 1. Okay. Second way, NPR equal to n factorial by n minus r factorial. That's all. Both are give same meaning. Both are give same results. Okay. But important note. IMP note. Very, very important. Okay. What is the relation between n and r none actually? They are countable numbers, no? That's countable numbers only. Okay. That too your r is always lesser than or equal to n. N distinct objects are there. From n I can select 1, I can select 2, I can select n, but I can't select more than n. No? That's why your r should be lesser than or equal to n. After selecting only you can arrange things. No? That's why your r should be lesser than or equal to n. That is one thing. Next, n may be equal to r. N may be equal to r. If n equal to r, what happened? That is important thing. If r equal to n equal to r equal to what? Npn equal to n factorial by n minus n factorial 0 factorial. So mathematical convenience 0 factorial treated as 1. So what you got? N factorial. Npn equal to n factorial. Npn equal to n factorial. What is the meaning of this? Npn equal to n factorial. Okay, leave it. What is the meaning? That is important. N distinct objects are given. From n distinct object, selecting r, arranging r in a row. Some arrangements will get. Each arrangement contains how many elements? R only, no, not n, R only. Because from these n elements, we selected R and we arranged it in a row. Okay. The R may be 1, R may be 2, R may be 3, R may be n also. What is the meaning of that? Selecting all. That is the result here. Npn means what happened? n different elements are given, selecting all the n different elements, arranging in a row, how many different ways you can arrange means I can say n factorial ways you can arrange. NPN means that one, NPN means from these n elements, selecting n means selecting all and arranging all in a row, how many ways you can arrange, that says this n factorial ways you can arrange. Okay. So, here repetition of things not allowed, that is important thing. Okay. Students, listen. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Total 6 digits are there here. How many 3-digit numbers you can write? That is the question. Question number 1. How many 3-digit numbers you can write? First case, no, that is no digit should repeat. Repetition not allowed. Means you can't 2, 2, 3, 4, 4, 2, like thumbs are not treated as required numbers. 3-digit numbers I want, like 2, 3, 4, 2, 4, 5, like that. How many? How many? We can't write practically all. We can, but it will take time. But by using permutation tool, how to find a solution? Listen, all of you. By using these 6 different digits, I want to make a 3-digit number. How many 3-digit number you can create? That is same as filling all these 6 elements, 6 digits in 3 blanks. Both are same. Both are give same meaning. First blank I can fill into 6 ways. Second blank 5 ways. Next blank I can fill into 4 ways. So, totally 4 into 5 into 6 3-digit numbers you can write. So, what is 120 3-digit numbers you can write? Simple, completed. So, by using permutation concept, how can write? How can how I did by using product rule, by using fundamental principle of counting, I completed the problem. By using permutation combination, how to write, how to find, both are give same meaning. Listen, all of you. From these 6, I want select 3. After that, I want to arrange in a row. Same meaning. That's why what I can say 6p3. How many 3-digit numbers you can get means I can 6p 3-digit numbers you can get. I think you people are following. 6 different digits are given. Nana. How many 3-digit numbers you can create? Already I proved. So, another way by using permutations concept, how to complete the problem. By using these 6 digits, first of all you want to select any 3. Those 3 should be arranged in a row. How many different you can arrange? Those many 3-digit numbers you will get. So, from these 6, selecting 3, arranging those 3 in a row, nothing but 6p3 in a permutation notation, 6p3. So, what is our answer? 6p3. What is value? Value, what is the value? Simple value means we can use any one of the formula, either this or this, to find the value. I will explain using both. By using first one, how can you say 6 should be reduced up to 3 times, 6 into 5 into 4. What you will get? Those many 3-digit numbers you can write. That is 120 only. By using second formula, what is saying second formula? N factorial by n minus r factorial. That is 6 factorial by 6 minus 3 factorial. 6 factorial means 6 into 5 into 4 into 3 into 2 into 1 by 3 factorial means these 3 factorial 1 into 3 cancel. What you will get? 5 into 4 into 6 into 5 into 4, that is equal to 120. Anyway, we will get 120. But solving problem by using permutations concept is important now than using product rule. So, the concept of NPR or the formula of NPR also derived from product rule only, by using product rule only. Okay, students, important thing, important notations. Once again, listen. Here 6 different digits are given. I want make a 4-digit number. 4-digit number. Condition 1, no digit is repeated. Condition 2, digits repeat, that we will discuss at last of the class. Okay. So, no digit will repeat. How many 4-digit numbers you can write? That is same as selecting 4 things from these 6. After selecting them, we need to arrange them in a row. That is nothing but 6p4. How many you will get 4-digit numbers? Directly I can say 6p4. 6p4, 4-digit numbers you will get. What is the value? 6 should be reduced 4 times. 6 into 5 into 4 into 3. 6 4s are 30, 12, 360 4-digit numbers you can write by using these digits. So, here one more case will be if any digit is repeated here, that is separate case. What is our first theorem? What is first case? What you are doing here? What you are doing here? The number of permutations of dissimilar things, and dissimilar things, all are different, That is our present case. Later we will discuss, some things will be repeat, how to find, how to arrange. That is not big problem for us. Okay, leave it that case now. So what I got? 360. You don't want to use for this notation, you want to use only product rule, you can use product rule, you can find the answer. That is not a big problem. Okay students, yeah, I hope you people understood now. Listen now, one more example problem, important example. Listen, by using digits 2, 7, 8, 9, 4, how many 3-digit numbers we can write, and how many of them are divisible by 2, or how many are divisible by 4. So this is interesting question. Okay students, listen, solution. First of all, how many are there? 1, 2, 3, 4, 5. 3-digit numbers you want. Try to draw a box containing 3 blanks. Just filling these 5 elements into these 3 blanks. How many ways you can fill directly? By using permutation concept, I can say 5p3. Directly I can say 5p3. These 5 different digits should be filled into these 3 blanks. How many ways you can fill? That says 5p3. How many 3-digit numbers you can write? Means I can say 5p3. What is the value of 5p3? We can find that in a big problem. 5 into 4 into 3. 5 for the 20, 60. So 60 3-digit number you can get. But among these 60, how many of them are divisible by 2 and how many of them are divisible by 4? That is difficult to ask, students. Listen. So these are 3-digit number. You get 60. I will write here. You will get 60. Okay, that is 5p3. You get 60. Among 60, one of the number is this nana. 2, 8, 9. One of the number. One of them is 2, 8, 4. One of them is 2, 8, 2, like that. So this is not divisible by 2. Unit digit is not divisible by 2. The total number is not divisible by 2. This is divisible by 2. This is divisible by 2. How many of them are divisible by 2 means among all these 60 digits, how many numbers are end with even number? Are divisible by 2 only, no? So how to find logically? I will explain. Listen. So listen students. Now the question is, among these 60 3-digit numbers, how many of are divisible by 2? Or indirectly I can say that how many of them are end with even number? Okay. So what is the meaning of that? This blank should be filled with only even number. This blank should be filled with only even number. How many even numbers are there? 1, 2, 3. 3 even numbers are. This blank can fill only in 3 ways. Okay. After filling this blank to 3 ways, now with us 2 blanks. How many elements are left with us, Nana? 1, 2, 3, 4. Because any one of the even number is filled, no? Here, any one of them. Now, 2 is filled means I can't. I can fill with 4 here, no? I can fill 4 here, no? That's why any one of the even number is can fill here. So what are the remaining things means? I can say remaining are again 4 things, 4 digits, 4 digits. Okay. So these 2 blanks can fill into how many ways? 4p2. 4p2 ways we can fill. One operation is 3 nana. Another operation is 4p2. From fundamental principle of counting, how many 3-digit numbers you can get? They are divisible by 2 means my answer is 4p2 into 3. 4p2 into 3. So 4p2, 12 into 3, 36. there are 36 3 digit numbers which are divisible by 2. I hope you people understood. Or once again listen, students, listen. Yeah, now we want to create a 3 digit numbers. Already I explained. We will get this 5p3, then we will get 60 3 digit numbers. Among 60, some are end with odd numbers also, those are not divisible by 2. So I want to identify among the 60 how many 3 digit numbers are there, they end with an even number. Means this box should filled with even number only, that is important. Nana. This box should filled with even number. How many even numbers are there with us? 1, 2, 3 only. I can fill this box with either with 2 or either with 8, either with 4 only. No? So 3 ways I can fill first blank. One operation is completed. Now I want to start second operation. What is our second operation? Filling these 2 blanks. How many elements are there with us to fill? Nana? Already 6, totally 1, 2, 3, 4, 5, totally 4. One element is gone here, remaining 4 only. No? Understood? Any one of them, any one of the even number only, using any one of the even number only you can fill the first blank. No, remaining 2 even numbers will with us to, we can use not to fill these 2 blanks. What I can say that there are 4 remaining digits. By using 4 digits, I want to fill into 2 blanks. I can fill into 4p2 ways. Directly, or 4 into 3 you can write, but directly I want to use permutation. 4p2 ways you can fill. 4 elements, 2 blanks. 4p2 ways you can fill. So this second operation. What is the first operation? 3 ways. From fundamental principle of counting. Why I am using fundamental principle of counting? Why I am using product rule? Why can't use sum rule? After completion of this operation, you can start this. Or after completion of this operation, you can start this. One is depend upon another. You need to use product rule. So total operation is 4p2 into 3. That is 4p2 value is 12. 12 into 3, that is 36. There are 36 3 digit numbers which are divisible by 2. I hope you people understood. Okay. So interesting thing is how many of them are divisible by 4. This is interesting thing. Listen. 2, 7, sorry. I want to write none. 7, 9, 2, 8, 4. Okay. What is the divisibility rule of 4? The 2 digit number formed by the last 2 digits of a given number is divisible by 4. The total number is divisible by 4. So what happened? Your last 2 digits means 24. Then the total number is divisible by 4. Understood? What is that? 48, 84. Try to write a possible 2 digit numbers which are divisible by 4. After that I can say answer how to find it. After that I will say how to find answer. Okay students. First 24. First of all I will start with, okay, one by one I will write now. Okay, I will write neatly. We will do one thing. We will write given numbers in order, then we will get correct idea. 2, 4, 7, 8, 9 nana. So we want a 3 digit number. So first of all I want to fill these 2. Later I will fill this blank. These 2. Okay, here I can use 2, here I can use 4, I can write any number here. So that is divisible by 4 only, no? I think if you write here 2 nana, 2 fix, 4 fix. No, 2, 4 completed. What are the remaining? 7 is there, 9 is there, 8 is there. I can write 7, 724 divisible by 4 only, 924 divisible by 4 only, 824 divisible by 4 only. In this way you want count nana. Logically you want count. Listen all of you. So listen. So I am finding the possible 2 digit number that can be filled with last 2 digits. 2, 4, 2, 8, okay, 2, 9 won't be, 4, 7 I think won't be, 4, 8, okay, divided by 8, 4 only. 4. What is one more thing? 84 also possible, no? 84 also divisible by 4 only. Now I want write. How to write steps? Number of 3 digit numbers end with 2, 4. See here students, blank name. So what happened here? Last 2 blanks should be filled with 2, 4 only. How many of them? So just we need to fill this blank. How many elements are there with us? 2 completed, no? Actually 2, 4, 7, 8, 9, 2, 4 completed, remaining 7, 8, 9, I can write here 7 or 8 or 9, 3 ways, means there are 3 3 digit numbers end with 2 4. Or another permutation notation, what I can say, 3 elements are there, I want to fill it one blank. How many ways I can fill means 3p1 ways, means 3p1 3 digit numbers exist which are end with 2 4. That is one thing. Next, number of 3 digit numbers end with 28. Same 2 8 fixed nana, just to fill one blank with 3, another 3p1, this 3p1, end with 2 for 3p1, end with 84 3p1, end with 84 3p1. Okay, so total 3 digit numbers which are divisible by 4 means I can say 3 plus 3p1 plus 3p1, 3 only, no, 3 plus 3, that is equal to 12. There are 12 3 digit numbers which are divisible by 4. I hope you people understood.